This is the fourth video of my advanced hardware course. In today's video, I'm going to introduce the FPGA implementation of the RC5 inverse function, which is the inverse of the simple function. And I'm going to display the last 16 digit, which is 4 hex number on the FPGA 7-segment LEDs. So let's first go through the VHDL code. As you can see in the VHDL code, I create a RC5 inverse top, which is important to be noticed that seg and n, which controls the LED, should be declared in the top module. If they are not declared in the top module, the 7-segment will not working because after the implementation, the FPGA cannot match this port on the corresponding port on FPGA. So these are the declaration of the signals, and I have created a save signal to store the last 16 digit of the output of inverse function. So I will create some component of RC5 inverse function and 7-segment display function and some clock wizard and UART. So these are the initialization of the UART. And in the port map part, I have also create an output save to connect the output save in the inverse function to this top module, and also I will give this save value to the 7-segment function hexvolt to display the last 16 digit, the 4 hex numbers on 7-segment. So after generate a base string, let's open the hardware manager. I have connected my basis 3 board to the FPGA to the computer. So let's open the HTerm and type in the input of the input function, which is zero 4 BI BE B6 and AB 797B, and that's the final output of the simple function. So here is the input of the inverse function. So after sending it to the FPGA, you should that the result should be FEDCBA 9876543210, and the result on the 7-segment is 3210, which is matched the output on the UART. That's the implementation of inverse functions on FPGA.